We are going to start by taking note of this little sketch here. We'll start by taking note of this little sketch here on how to calculate the number of rows for a building project. Now, let's count how many pillars we have in this sketch. 1, 2, 3, 4, 5, 6. We have 4 pillars here. And here is a little section that is cut. Now, look at this. We just showed internal or how the foundation looks like, and they said that it should be 4y16. Young engineers will understand this. Clients should also understand it. What it means, 4 bar of y16 should be used to do the starter pillar. Here is the dimension. So here is the height of building. Just take good note of it. Now, to start the calculation of the number of rods for a building project, step 1 is to calculate the starter bar. Like I told you, this is not for entertainment purposes. This is just for learning purposes. Just follow my hand and learn. Now, step 1 is calculate for the starter bar. That is it. You can call it starter bar or you call it the starter pillar. Now, the first thing you do in calculating for the starter bar is to take note of the dimensions of travel of the starter bar. Starter bar, that is the first pillar that comes out from the foundation into the ground floor. That is what we call the starter bar. Now, we are going to take note of the dimension. Pay close attention. Here, for me, in practice, I usually bend here the bottom of this pillar to be 250. Now, we say 250 millimeter. I did it on purpose. Now, let's say the height of the concreting, which is from here to here after the blinding, is 450 millimeter. That is 450 millimeter. Now, the next thing is the height of the foundation. Let's say the height of the foundation as recorded in the drawing from here to here is 1,500 millimeter, which is 1.5 meter. That is 1,500 millimeter. That is, we are trying to get the length of travel of the starter bar. Now, the next one is the DPC, which is 150 millimeter. We add it 150 millimeter. Now, there is one thing that you must note. The one that will project out of the DPC, we usually call that one the lapping length. In my previous reels on Facebook, I have taught you how to calculate the lapping length. Now, I'm going to show it to you again. That is the final one we should get now, the lapping length. What is the lapping length? Lapping length is simply the lap length that a rod will lap together. That's during construction. That is it. From distance from here to here is just that lapping length. And there's a formula for it. I tell you the formula is 50D. D is the diameter of the rod. Now for here, 50 should be 50 times 16 millimeter diameter, which is 50 times 16 is 800 millimeter. That is it here. From here to here, 800 millimeter. Always use that formula when calculating the lapping length. 800. Now let's calculate together. Remember, before you get the starter bar, you calculate the dimension of travel of the starter bar. Let's add it together. Let's use our calculator. Our calculator says is 3150. 3150. millimeter. That's what our calculator says. And it is approximately, if you convert it to meter, it's approximately 3.15 meter. But in practice, there is no way we will start cutting 3.5 meter for this. You know fully well that the length of a rod is always 12 meter. If we cut the 3.5, we will have a lot of off-cut in the west. In practice, we approximate this to 3 meter. That is what we got, 3 meter for each length of the starter bar. Now, they say this 3 meter we have gotten now 3 meter, which is one length of the bar, times how many rod did they say, did they recommend, the structural engineer recommend 4. It should be 4. They said 4 times how many pillars do we have here? You say 1, 2, 3, 4, 5, 6. Look at it, times 6. What do we get? 3 times 4 times 6. What do we get? Let's use our calculator. Our calculator says 72 meter. 72 meter. That's what our calculator says. Now, once you get this 72 meter, take note that the length of one length of rod, the length of one length of rod is 12 meter. Therefore, to know the number of length in these 72 meters, you do 72 divided by 12. That is it. This represents the length of one rod. That is 12 meter, which is, let's use our calculator, which is 6. It means 6 length of 60 mm rod. We have gotten the first one. The first one, which is the starter bar. Now, the next one that we are going to calculate is to calculate for the ground floor, the pillar that will be from the ground floor and project into the first floor. Look at it, the pillar will move from here and project into the first floor. Now we are going to calculate it. Now, remember the first thing that we do, that's step 2. We call it step 2. Calculate the pillars in the ground floor. How do we start? We start by taking note of the dimensions of travel of the pillar. Now, what is the dimension of travel? Number 1 is from here to here, which is 3000 millimeter, equivalent to 3 meter. We call it 3000 millimeter. We have gotten the first one. The second one is, remember, what we took is from here to here, to the roof of the bottom deck. Now the next one is from here to here, which is the slab length, which is 150 millimeter. That's what we assume. 150 millimeter. Then the next length of travel of the rod is the same lapping length. Lapping length that we brought out. Now, the lapping length is what? 800. I've already told you how we got the lapping length. What is it? 0593. And this is our product. We will not be having a lot of off-cut. Approximately, in practice, approximately 4 meter, or you can say 4000 millimeter. Now we have gotten the length of one bar, which is 4 meter, and we are told that it should be remain 4 bars of 16 mm. So what does it mean? 1 bar 4 meter times the 4 bar that is required times the how many pillars that is in the building, which is 1, 2, 3, 4, 5, 6. 6 equal to, let's use our calculator. Our calculator says that it is 96 meter. 96 meter. That's what it is. Remember, the same thing, one length of rod is 12 meter. Therefore, 96 divided by 12 to find the number of rods that we will buy for the ground floor. When you divide it, you get 8 length of Y16 rod, or you call it 16 rod. We have gotten the pillar that will be in the ground floor of this building. Now, the step 3, we are going to step 3. Step 3 is nothing else but the rod that will be from this ground floor, from this first floor, and enter into the roof. Carry the roof beam and then to the roof. Did you see it? Hope you are following. That is it. Now, that is step 3. You can use this method and calculate for even if you are doing 3-story or 4-story or 5-story or even 2-story, you can use this same method. But now we are using this simple format to show you how it is done. Now we are going to calculate from this first floor to the roof. Now, there is something I want you to note in this. When we are calculating for this one to the roof, there is a difference. The external walls, let me show you. The external walls are not calculated the same way with the internal walls. What do I mean? The external pillars are done differently from the internal pillars. Now, the external pillars are done using 4 meter height. 4 meter height directly. I'll show you, but the internal pillar are done using 3 meter height. What do I mean? Let me show you. This pillar, this bar, will travel in external walls that will carry the roof, will travel from here, enter the roof beam. Once it enters the roof beam, it goes to carry the parapet. But the internal pillar stopped here. It moves from here and stopped here. You understand? Now let me show you. For this purpose, I'm going to show you the first thing is the first length of travel is 3 meter, which is 3,000 millimeter from here to here. Look at it. 3,000 millimeter. Remember, we are calculating for the first floor pillar, 3,000 millimeter. Now, the second length of travel of our external pillar is the roof beam, which is, you can call it 300 millimeter, or you say it's 225. Look at it. You can call it 300 millimeter. Now, it's 3,300 millimeter. Approximately, you can call it 3.3 meter. Now we do it so that 4 meters, so that the shootout of it will take care of the parapet once it is bended inside the parapet, so that it will be able to carry the parapet. That is it. Now we approximate it to 4 meter. That is it. Now this 4 meter, how many bar? They say it should remain 4 bar according to the structural design, which you see. It should remain 4 bar, then times the number of pillars, which is 6. Almost the same thing with the ground floor. What is it? 4 times 4 times 6, which is the same 96 meter. When you must have divided 96 divided by 12, you get 8 length of 16 rod. That is it. Now let's calculate together the total number of rod that should be used in building this house. That's what we are going to do now. The first one is, let's calculate them together. 6 length, the total equals to 6 length plus the second one, 8 length, plus the third one, 8 length. So the total is, when we use 6 plus 8 plus 8, that's 16 plus 6. That's the approximate, we call it 22. We call it 22 length of Y16. 22 length of Y16 rod. That is what is required to construct this house. That is it, very simple. This is the simple way to calculate the number of rods for a building project. It's very simple. Here could be 6, here could be 8. You just take what the drawing shows you and you calculate for the total number of rods required. Very simple and short. So young engineers, you shouldn't fear doing this. You shouldn't fear doing this, because there is one of our young engineers that chatted me and said that he underquoted and he is now having problem with the client. I told him, don't worry, I'm going to put it out on Facebook so that you see the teaching. So here it is. Now the next thing I'm going to do, as I said, I'll break it down step one by one. I'm going to be calculating how to do the calculation for the stirrups, how to do the calculation for the basket, and how to do the calculation for the lintel rods. I'll use simple examples so that you see them at the end. We have broken it down and see how to calculate the number of rods that should be used in a building. Thank you very much for watching. Please share and tell your friends. It's the easy way. Let's learn together and get better as an engineer in this country. God bless you all.